So here it is interesting. Okay. Now don't play to me because then I don't know. Okay. Now don't play to me because then I don't know. Okay, seems that.
Jesus Christ. And we start over.
Damn! Here we always have something. Somebody is making a course on us. Let's see what people is commenting in the chat. I hear you now, says Mr. Stefano Grigio. Thank you, Stefano, that you can hear us.
Thank you, Stefano. Very cool.
Not sure what happened there, but now we are back on. So, good thing that this happened at the beginning. We can cut and we can tell people to start at the minute, whatever.
Fortunately, our lovely assistant let us know that the audio was off and we didn't stream for an hour without recording any audio.
So, here we are. What we were saying, to recap very fast.
In fact, I don't want to recap very fast. I think it's worth to go back through from the beginning. Let's
Okay.
make sure that our point gets across.
Okay, welcome to today's episode of Roberto and Barton Research and Development. Is the episode number 8, but it's not yet the number 1 that work everything okay from the beginning. We are -7 probably to perfection. Today's topic is smart contracts. Are smart contracts really smart? And how did they come along? What is the use of a smart contract in a blockchain? What can be done better? Let me try to give you the intro that before has been given by Barton. We switch roles for once.
Okay.
First blockchain invented has been Bitcoin, right? Some people can discuss the first blockchain was something invented a long time ago to keep data, but as we know it today, the concept of blockchain as a decentralized network of a computer that hold the data for managing assets is Bitcoin. While Bitcoin truly has a small scripting language that nobody really use, the main function of Bitcoin is essentially to send the funds from a person to another. You don't really do anything else with Bitcoin, okay? There are some exceptions. People record hashes of document to give a proof of existence, but principally is using the same functionality. Doesn't do much thing. You cannot do voting, for example. You cannot create assets. You cannot do many other things that a lot of other blockchain are today offering. Personally, I've been working a lot with Next NXT, which is the first known clone of Bitcoin, and didn't present itself as a system to manage a token or a coin. Presented itself as a system to implement a decentralized application, a decentralized application platform. And for this reason, it had a lot of functionalities embedded in the core of the blockchain. It doesn't have smart contract, which means that with the blockchain you can cast votes, you can have a decision making based on the result of other things, action of several kinds through transaction in the blockchain. Vitalik Buterin is a Canadian-born Russian super smart guy that if he was decentralizing his brain who had enough for all the humanity, I think, came out with an idea to make another blockchain that could do different things than just what Bitcoin does, pretty much what NXT went through. And after started experimenting to do one particular transaction type, one particular functionality, he started thinking, why don't we allow people to code their own functionalities, to code their own transaction types? Because the transaction type is a little bit of a flow that is embedded and coded in the blockchain, in the mechanics of the blockchain, he put a sort of virtual machine, without sort of, a virtual machine, with
it's called the Ethereum virtual machine.
Exactly, which can be coded with several languages once compiled. The most common is Solidity. People can write code and this is saved as a transaction in the blockchain. When it's needed, people can call their application that is executed in every node virtual machine with the parameters that are necessary to execute, and the application return a result, and people pay for this functionality.
If the virtual machine is coded correctly on all nodes, then all of the nodes return the same result. But as we'll discuss later, that is a big if.
Well, obviously, once you deploy once, so it's copied identical in all the nodes. So cannot be the one node that return one thing and another node return another thing unless they are different virtual machine, different version of the Ethereum software. So these two very much. Yes.
Now I try to take the part that Roberto usually explains, which is that one of the first difficulties we notice with this smart contract approach is that when we start to think of really, they kind of tried to build an operating system in the blockchain onto which you deploy software. But typically, an operating system has a lot of functions built into it for common things that you like to do. For example, there's a whole set of tools on pretty much any modern operating system that you use that manage copy and paste. You know this keyboard shortcut by hand, probably. And the copy and paste is not something that you code into every single application. It's something that's supported at the operating system level, and it handles any kind of differences at the operating system level, but it creates a kind of a guarantee of available behavior. And this is only one of many examples: network access, file system access, things like this. By analogy, in the Ethereum smart contracts, many of these things that you would hope would be kind of available to all have to actually be recoded per smart contract or deployed by one smart contract library that's called by others. And this was something that was actually a deliberate design decision by Vitalik, which he decided early on, as long as we're going to put the complexity of this whole virtual machine into the software, then any piece of complex logic that exists should be moved outside of the core, above the level of this virtual machine, so that we handle all the complexity there.
What happened later? That somebody writes some very cool piece of code, smart contracts, a very interesting smart contract that everybody loves and everybody uses, so it became a very popular smart contract. For example, ERC20. ERC20 is a smart contract that allows people to create a token on the Ethereum blockchain, mostly used for ICO. The ERC20 is a big chunk of code in smart contract terms, let's say, and is deployed every time people want to create a new token. Sometimes it's deployed, then they realize they made a mistake, they redeploy, etc., etc. My first comment, and I had the luck to have a chat, online chat, but video chat before a conference with the guy that invented the ERC20, so the claims, together with Vitalik. And because I explained in long terms the work we're doing with ZooBC, which is our blockchain platform, that approach all this issue in a different way. We're gonna explain this later. It was trying to understand and very openly try to see the points that are good or not about a different approach. My point to him was this. Let's say that the ERC20 is a big 100. I say just a number to have a reference, okay? And everybody deploying the ERC20, which are thousands if not millions of people, all the deployment that have been done, modify only 5 of these 100. So 5 can be customized for particular need, 10 say. The remaining 95 is always the same. And I said, it wouldn't be worth in the next release of the Ethereum core node software to create a functionality, transaction type that is the ERC20, that take as a parameter, as deployment, only the modifiers. Would this make it much more effective? It doesn't run into a virtual machine but run in the actual core, faster, more secure, less expensive in terms of gas, and guaranteeing, because every time I see an ERC20, people can change the code and make some behavior that are different from the classic ERC20. How do I know? I need to go and read through the code. There are, like Etherscan says, this contract is very similar to this other. Etherscan is an online service to investigate the Ethereum blockchain. So I know that pretty much ERC20 respect the standard ERC20, but do I know which 5% they change around it? I don't know. So unless I become an expert and start looking, I may be investing in an ICO where the ERC20 code is such that everything explodes after a while or whatever else, right?
So one complexity I think you're getting at in general here is that you have to be a full-fledged Ethereum smart contract developer to understand whether something deployed on the network functions the way that it's supposed to, or even to understand whether it's going to be secure when it's deployed. And I think for anybody who's tried to code a smart contract or pay for one to be coded, it's not that cheap to get it done. It's a very specialized skill. The review is very expensive, all of these aspects.
For a good reason, because once you deploy the smart contract in an immutable ledger, an immutable blockchain, that's cannot be changed. So there is a bug in the code.
And in fact, let's present this point in the correct light. This is very important. The fact that a smart contract, once it's deployed, cannot be changed is not an accident. It's in fact part of the reason that they called it a contract instead of a program. The idea is that by forcing the code that's deployed to be immutable, to be unchangeable, once somebody does comprehend the rules of that program that have been deployed on the network, they can count on those rules to stay the same no matter what. So once it's deployed, nobody, not even the creator of the contract, unless the rules in the contract stipulate that he's allowed to make changes to it, nobody can actually go in and modify in general the behavior of that program anymore. So it becomes a safe platform to trust that code will be executed neutrally by the entire network indefinitely into the future, so long as the greater property that the blockchain's decentralization holds.
Which means that once that you are assured that the smart contract does what you need to do, it doesn't do what you're afraid it could actually do, you don't need to go check again the code every time you use it. Because once you guarantee you have the unique ID of the contract, you know that's the contract and that's going to be the behavior.
Once you put $10 million of your Ethereum into the smart contract, you don't have to worry that the smart contract author is going to sneak in and put all the funds to himself.
And that's what happened to a very infamous smart contract called the DAO, the Decentralized Autonomous Organization.
So this, the DAO is a very nice story, and it's one of these stories of, it's like the Icarus story, right? Of flying too close to the sun and your wings melting off. It's the story of human hubris, right? So people got so confident in this idea of a general smart contract that they decided at some point that they're going to build this magnificent machine and launch it immutably in the cloud, in the Ethereum network. And this machine is going to, I don't even remember all the things it does.
Crowdfunding.
It tracks all of the money that people put into projects. They can put to each project. It gives people the ability to register the projects they're going to track, and people become investors of projects. And these projects wind up having tasks or bounties that they can pay out to other things. And they built this enormously complex application and deployed the whole thing in Ethereum smart contracts. And since then, the DAO has been running fantastically, and it funds most of the projects on the internet.
But
or is that true?
But it's not true, because there was a small conceptual error in the code. This DAO was implemented by a software house in Germany, specialized in smart contracts, and they made a conceptual error. So once people were tired of leaving the money, their own Ethereum in this DAO, they could withdraw. Okay, like if it's a bank where you leave a deposit and then you withdraw. The the DAO was keeping all the Ethereum collected in a big bucket, okay, like an account with all the collected money, and was having its own ledger with the balance of each account that was making a deposit there. So let's say I put 1,000 Ethereum, and my 1,000 Ethereum are accounted as my account as 1,000 Ethereum. In the moment that I want to withdraw, I send an instruction to the smart contract, and the smart contract will send the Ethereum to me. The problem is that in the sequence of doing this, rather than removing the $1,000 from the balance of the big bucket and then sending them to me, he was doing the opposite. He was sending them to me and then removing it from the big bucket. Somebody noticed that if the contract was called in the middle of this operation, it would interrupt what it was doing and restart over. Which means that if I deposit 1,000 and I ask to withdraw 1,000, the 1,000 are sent to me, I call the contract again, asking to give me 1,000. Now my balance is still 1,000 because it's not been modified, and I'm getting another 1,000. Before my balance goes to zero, I call the contract again, the contract says that I have 1,000 and send me another 1,000. And in this way I can withdraw my deposit multiple times, obviously at the damage of the big deposit that used to belong of the other people.
Which in technical terms is called a reentrance attack in Ethereum smart contracts.
Okay, people do it with banks too, can you imagine? So in doing this, it took some time. People noticed that the big balance was going down, and some white hat hacker understood the mechanics, started doing the same identical attack to empty the fund as well, to collect the rest of the money to return to the people. Naturally, they couldn't stop the program. They couldn't kill it. Because the code is immutable, it's there, and anybody can always call it.
It's not supposed to be changeable.
So, or you shut down the full blockchain, or you accept that the people run the application the way that...
Which, this failure, as it turns out, was so epically catastrophic that the whole Ethereum community, rallied by Vitalik Buterin himself, decided by the force of the fact that they could convince the majority of the network that they were going to deploy a new fork of the entire history. So here's where the DAO is happening, and the DAO catastrophe happened here. And they got most people to agree to roll back to here before it happened, branch off a new version of the blockchain, and continue in parallel. They never convinced this other 10% to stop running the version where the DAO catastrophe happened. That's now called Ethereum Classic.
In fact, the Ethereum Classic is the actual original Ethereum. They decided to rewrite history. Pretty much they rewrote the blockchain as it was, excluding the transaction where the DAO was created, with the consequence that every deposit made to another that doesn't exist was bouncing back, and the blockchain rebuilt to the current state. So if somebody made a payment, the payment was still added to the blockchain, but all the transfer related to the DAO were not there.
What we learned from this? The lesson, in our opinion, is not that that German software house should have been so smart as to never ever possibly make such a mistake in their code. I don't think any person on the planet, any software organization, has ever, if you've worked in a big software organization, have you ever deployed 100,000 lines program and found every single bug that exists in it on day one? No, there's bugs in that thing that you don't find for years until people notice them in strange corner cases. That's the nature of software. And that's part of the nature of software that Ethereum, in its promise to make really immutable code, didn't fully take into account. And it's so Ethereum, one of its weaknesses is that it doesn't have a really standardized, explicit process for how a piece of code can run on the network until it reaches a certain level of maturity and it reaches a certain level of community debugging and things like that. There's they let people deploy on testnet to test it around, and they let people create these kind of, we'll talk more later about gateway contracts that create a kind of a loophole where the creator can change the code that runs and things like that. But these are mostly kind of hacks around what you really should be able to do, which is manage a running software application, even a decentralized one. And it's a kind of management that you're able to do in principle in another blockchain, as long as you get the majority of the network, of the actual node operators, to agree to a behavior change that fixes the bugs and things like this.
There are other issues with smart contract, for example. Let's say today Ethereum has a virtual machine version 1.3 per se, okay? I write my smart contract and runs perfectly. This is what happened to an exchange that coded their own smart contract in order to manage the funds of the people that made deposits. Then Ethereum comes out with a new node software and the virtual machine is updated to 1.4. The version 1.4 has something different for which the smart contract of this exchange stopped working. And all the money and all the Ethereum that are in that smart contract cannot be taken out anymore, because when the instruction is sent to make a withdrawal, the application crashes or doesn't execute. And they made not change to the smart contract, but the virtual machine changed, which is a normal thing because virtual machine need to mature and grow, but I should be able to also change my code to match the new version of many times in your iPhone, the operating system updates, and the software, the application you have, they need to update to match the latest operating system. But this in the functioning of the smart contract with Ethereum has not been possible, and these people lost their money. So that's another point to consider.
Another trickiness, another technicality. And these aren't the only times. Say, one of our other favorite stories about this is a few years ago, there was a particular smart contract that was deployed by a very reputable company called Parity. And Parity is the creator of one of the most popular Ethereum node implementations. I think they have an Ethereum wallet implementation. They've written a lot of public smart contracts that people are supposed to use. So Parity is a very trusted organization when it comes to writing smart contracts. One of their popular smart contracts managed multi-signature transactions. So this is one of those things that Vitalik in the beginning said, hey, it's complicated, like anything too complicated, we push above the level of the Ethereum virtual machine. So if people want multi-signature, they can write smart contracts to manage their own multi-signature. And so Parity did. They wrote a smart contract to manage multi-signature, which held a lot of funds in escrow that are controlled by multiple parties.
Consider this, if you have $100, you don't go to bother to have a multi-signature where many people have to sign to spend their money. If you do that, it's because you are like an online casino,
It's because you have millions of dollars.
And you keep a consistent amount of funds in the multi-signature, right?
So this smart contract held a huge amount of funds in escrow on the network, waiting for the correct number of signers of each different account balance to actually authorize it to be moved.
Consider that it was being deployed hundreds, not thousands of times, this smart contract, which means that people took the code from Parity, copied the code, pasted and deployed on their own. So there were many copies of this smart contract.
However, the fatal flaw in this case was that all of those copies of the smart contract called a function in another particular smart contract that was already running on the network.
Which was only one for all of them. So it's not that every copy had its own copy of this dependency. So all of them had dependence on a single other smart contract, right?
And this dependency, this particular little library, some developer came along one day and he noticed that the initialization function on the contract had not been called. Or the destroy
Which means
something. Basically, this guy took some kind of minor action. I don't remember exactly what it was, but essentially, he took some kind of minor action that was legal for literally any account on the blockchain to do, and this caused that library to finish. It stopped.
So the dependency contract that all these multi-signature were using stopped working.
To all stop, and all of the millions and millions of dollars worth of Ethereum that were managed in these set of smart contracts for multi-signature capability were suddenly frozen. They were completely inaccessible to anyone. And this time, Vitalik Buterin's money was not in the pot.
The legend says that during the DAO, a lot of Ethereum belonging to Vitalik was there. That's why Vitalik led this revolution in rewriting the blockchain, and a group of people refused to change history, and that's where Ethereum Classic was born. This time, there were no use of the multisig, for which probably the interest of restarting the blockchain,
so
rewriting history.
This time, the money is just lost. All of those people who had the money there,
gone.
So
what we learn out of all this?
I give one more example just because it's one that we ran into personally. And this one's, so we argued in favor earlier that the operating system itself should provide some very specific, common functionalities. But even for these functionalities, it's important that the operating system provides them correctly. And we ran into this problem in a smart contract for Ethereum that we were developing recently, which, for one reason or other, needed to use the SHA-3 hash function, secure hash function 3. So this is one that all of our tools that we're using in ZooBC use the SHA-3 hash function because it's the most advanced, trusted one at the time. Ethereum also uses the SHA-3 hash function, and so naturally we expected that when we compute a SHA-3 hash in Ethereum, we get the same result that we'd get in our blockchain or any of our other tools. This turned out to not be true. In fact, Ethereum blockchain started back before SHA-3 was technically formalized, back before its parameters, the parameters of the algorithm, were defined. And so Ethereum uses something that should more properly be called Kechik 256, which was the precursor algorithm, or kind of the framework on which the SHA-3 hash algorithm was created. But they're slightly technically different, and this means that they produce completely different hashing results. So what this means is that any smart contract on Ethereum that calls the SHA-3 function, which should be an industry-wide standard, actually does not get the SHA-3 hash that every other application which uses the standard version would expect. And this is the kind of thing that also you would like to think that maybe in one of their change-breaking Ethereum virtual machine upgrades, they would be able to fix this problem, or at least enable people to access the actual SHA-3 in parallel. But so far, it's been so fundamentally central to the entire Ethereum stack, the way the entire implementation works, that they just left it as Kechik 256. We were unable to code a somewhat important function in a smart contract we were developing because it doesn't support SHA-3 correctly.
And this is another example, but staying to the original philosophy, we should have created a smart contract that does the SHA-3 calculation, right?
Which we can. It's just horrifically expensive in terms of Ethereum gas. Running code on the Ethereum virtual machine is not very performant. In fact, the Ethereum virtual machine has to do a lot of complicated things. The virtual machine has to count every instruction that happens. it has a lot of exception handling instructions. Basically, at any given instruction in the execution, that if that runs out of gas, if you surpass your limit, then it's going to fail out. It's a very heavy thing to execute at the technical level.
Oh, the smart contract, but this is to be blamed the developer. Had a function to deposit funds in the smart contract which ran. The function to withdraw was too big of a computation that reached the gas limit, and the funds cannot be recovered anymore.
And so probably the last feature of smart contracts to talk about is that there is a kind of a band-aid solution in Ethereum smart contracts for the major problem that we're talking about, which is the code cannot be redeployed. And that's the idea that you can have a thing called a gateway contract. So a gateway contract is a little stub, just a little piece of logic that lives on the blockchain that says, when a function call comes in here, look up this certain contract address and call the same function there. And this contract address can be changed by the owner of this little gateway. So
in this way, say if I find that there is an error, a bug in the code of my smart contract, I deployed a new one, and I use the new one instead of the old one, but the address of my original smart contract remains the same. So people can be relaxed that if there are issues, they can be addressed and fixed. Problem is that people can even change the logic to steal all the money or to do
if
other
this is
things.
true, it undermines the entire purpose of having
Decentralized.
of having immutable smart contract. So at that point, it's not really a contract. It's just moving terms of conditions. It's whatever the deployer feels like.
So at this point, the approach is there are two approaches. Now think this: if the smart contract was living independently in every node, and there is a bug, and it is the will of the owner of the node to fix it, you will need the majority of the node owner to make the same fix to have a successful consensus in the result of the smart contract functionality, right? In this way, it's not the owner of the smart contract that make the change and cheat everybody, but is the majority that want to address this issue, also because sometimes malicious people release the initial contract, people want to make a change. Second, a lot of functionality that are redundant between all the smart contracts, they don't need to live in the smart contract. They don't need to live above, even if they are in a form of a library, they need to be compiled. Still, they don't need to live in the contract, in the smart contract. They can live in the core part of the node software, leaving to the smart contract just the intelligent part, let's say, the changing logic of what the smart contract should do. Guaranteeing that first, the person that codes the smart contract doesn't have to know all the concept of decentralization, because those are taken care by the node software, right? And when he needs his smart contract to work in a certain way, he can just rely on the core node software to apply the logic that are embedded there to the smart contract.
So now, let's talk about two different approaches to decentralized applications. First, we go backwards, which is to the first thing that Vitalik Buterin got annoyed with designing these custom transaction types that was done in the NXT blockchain, like Roberto mentioned, which is that you can have a set of transaction types that exist in the blockchain, which give the power they give a set of certain functions that are pre-coded, pre-engineered by people who know the blockchain code by heart, and which can be fixed by the majority of the network. If the majority of the network agrees that they don't behave the way that they're supposed to do. And as long as people are able to build the applications that they need on the blockchain out of a couple of these fundamental building blocks, then they're able to have nice decentralized powers that they can rely on, decentralized confidence for key parts of their application. and they are not required to understand in detail every single piece of logic in a smart contract. They're not beholden to the fact that some bug in the expensive implementation that they paid for is going to cause their whole, like all their funds to be lost or something like that. So it's much simpler. However, this is only, and this in our very first release of the ZooBC technology is the strategy that we're taking. We recognize that smart contracts are very general, but we're so wary of this set of problems that have come from smart contracts that we don't want to enter into that space even. So in our very first version of the ZooBC technology, we plan to build just such a set of tools, which we think are the most common tools that most people need, and we're actually going to let people build only using those tools, which we can personally guarantee work well. Going forward, there's a second thing. So that was looking to the past. Now we look to the future of what can be done with decentralized applications. And a decentralized application does not have to be a smart contract. I think, like many good ideas, when smart contracts started, they were so revolutionary that they created a kind of box around the kind of ideas that people were willing to think about when it comes to how a decentralized application operates. You can see this in the fact that many other blockchain technologies now are scrambling to have their own smart contracts which work exactly the same way. There's a virtual machine, it executes the same way on every node, it runs in a very careful sandbox, it counts the instructions to see how expensive the fees should be. They took the same model and cloned it over and over again. We think this is not the end game for decentralized applications. In fact, for our second version of the ZooBC technology, we're in the design process for a fundamentally different smart contract platform, which would allow traditional software, say web development techniques, web server development techniques, to use a kind of a framework of tools connected to the blockchain to make sure that they run many redundant copies on the network, that makes sure that people have the choice for which decentralized applications they're going to deploy based on which ones are actually going to reward them from the service, which give an explicit upgrade path in terms of the governance for whether an application that exists in the decentralized space is still in its development phase where things can change and they're finding bugs, or whether it's matured to a community management phase where only the entire community or the majority users of that application are allowed to authorize a change to the software, all the way up to, eventually, the immutable level that they exist in something like Ethereum, where the code for that decentralized application cannot be changed anymore, and it can become a building block on top of which other decentralized applications can be created.
Trying to look at reality. Now, even the Guinness World Record book, the Book of World Records by Guinness, lists a developer that made the piece of code working at the first attempt.
No, never.
This is something that should make us think about it, you know. Why? Is because it's impossible to think beforehand all the possibilities, all the changes that we can only learn by using it. And on this philosophy, we understand that something decentralized, the difference between a decentralized application and an application that is running in your computer, let's say a word processor. When you call a word processor, you execute it, it runs, you see that there is a bug, stop it, change it, execute it again, and when you distribute, then you give an update, people install the update, and it's gonna run. Okay. But a blockchain is a living animal. A blockchain never stops. You cannot stop and reset the blockchain. Or we do it with the testnet, with the alpha version, because we're working on it. But once the mainnet, a main blockchain is started, this is a system that has the longest uptime of history. Bitcoin never being down. I mean, some node down, other node down, but never all of them. So, as a together system is always being alive. Now, if you have an application running on something that is alive, you cannot afford to restart it. But with the mechanics that we are implementing, we can leave different phases of an application, right? So we can start with a phase where the first prototype are made and people use them, but they are not drastically important, so people don't put real funds. Then things are adjusted, people vote, give feedback. There is the normal life cycle of an application until it's mature. When it's mature, usually has a milestone landmark that is version 1. Now, version 1 can get frozen, and it becomes the standard that that no other things are gonna happen or change of behavior. And this is a very different, beautiful new approach to decentralized application. Not only those are not smart contracts, meaning that the functionality can be a full application that can do very complex things, can work with even attached devices, can work with CR, voice recognition, machine learning, and other things. You cannot run machine learning in a smart contract, correct?
So, in fact, let's talk about a few of the things that we hope to implement and kind of move forward in this decentralized application space. Consider this is still a work in progress. We don't have all the answers yet, but we have several lines of thinking, several strategies that we're developing, and kind of theoretical properties that we'd like to have. One, we would like to attain scalability that, say, the Ethereum blockchain in its current form doesn't have. Ethereum 2 is going to have sharding and blah, 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 in theory. But for now, every piece of code runs on every single computer on the Ethereum network. We saw this problem with big ICOs that happen and clog up the whole network. We saw the problem with CryptoKitties. The CryptoKitties, when everybody was trading them, nobody else's Ethereum application would work properly. So, one thing that we get is by having a free market for every node operator to choose which computing resources he wants to contribute to the network and which of these applications he actually cares to run based on how much they're going to reward him in the network's tokens for running that application. We help guarantee that applications, the very popular ones, will still have a wide degree of decentralization, but these don't have to run on every single computer in the network. So this means that you can have, out of a very large network, it doesn't have to be replicated to all. You can have big pools that run particular applications that give the power of decentralization and the trust that it can't be changed. But you don't run into the problem that any one contract completely clogs the network. A second power that we get from this has to do with finding developer talent and things like this. We want to abandon completely the idea of running in a single sandboxed virtual machine. We want to let people write code in any potential. Oh, what happened there? We want to let people write code in whatever conventional web programming platform they're comfortable in. They can write it in Rust, they can write it in Go, they can write it in C++, they can write it in Node.js server. And it's not going to count instructions or anything like this. It's not going to guarantee that they don't call out to the internet or access certain functions or things like this. Enforcement of the fact that the work has been done correctly will be defined at a different kind of a protocol level. This is one of the very complicated pieces that we're still working out exactly how we want to approach, but we have some ideas for how to do it to guarantee that these things are actually doing the correct work. And once you have this, then, like Roberto was saying earlier, we have the idea that not only can this be a decentralized computing platform, this can also become a distributed computing platform because it's up to any given decentralized application developer to make decisions about how many times a particular piece of work is replicated across the network and used to check that people did the work correctly. It can be used to make sure that even within an application, the same work doesn't have to be done by all the nodes. It can actually be shared around to a level of decentralization that's suitable for that particular application. And also, we gain the fact that there are thousands and millions of frameworks and tools and existing code that's been tried and tested in web development for years and years. We have thousands upon thousands of developers who are skilled in this web framework development. There's a massive skill base out there that does this, and is if these people can learn to work against a certain framework that confines them in certain aspects to the rules of the blockchain or the decentralized application, but otherwise allows them to code whatever they want, knowing that their code is going to be inspected and used as a basis to determine whether other people should trust the application that they've developed, then this means that we capitalize on tons and tons of existing code and work in the past that exists out there. We move away from all of the efficiency limitations of the Ethereum smart contracts. We move away from needing highly hyper-specialized smart contract developers in order to write any of the code for this thing. Really, we get a generality.
The idea is this: if I'm comfortable coding in Perl and I do my things, I don't know about the centralized system, I can write, spin off my Linux machine, write my code, and do my things, right? And this is put inside a sandbox that stands in all the nodes of a ZooBC blockchain. This sandbox avoids that my application can have any effect in the machine outside the sandbox. So I can have my own file inside, I can delete, remove whatever I want, but I cannot touch anything outside. And the interaction with the blockchain are managed by the let's say the borderline of the sandbox with the node. So the node take care of there is a fee, there is a token that has to come in, there is this digital signature is approved or not, is validated, the hash is okay or not okay. All things that happen outside the sandbox where the application is running, but can communicate or fish data out of the application. In this way, the developer develop the application, deploy the application. It can do Ruby on Rails, can do in C++, can do in Perl, can do in COBOL, whatever else, in Visual Basic, whatever it is inside the sandbox. This has a certain resource consumption, doesn't have to run in all the nodes of the blockchain, but just in a subset of nodes. And whenever a user posts a transaction in the blockchain for the particular application, this transaction has metadata that are common to all the blockchain where the fee are paid, and another block of payload of data that are just related to the application. So all the nodes that run the application, the peer-to-peer is going to distribute to them this payload to be processed through the application. But the rest of the node just take care about the fees and whatever other validity of signature, etc., etc. In this way, even if there is the CryptoKitties, it would affect only the set of nodes that are running. Give an incentive to anybody else that has a node that has enough resources to also run the application, because it's gonna get more rewards, and making the work lesser heavy for the old nodes. So it's a self-regulating, organically regulating balance between what resources are put for what application based on the popularity of the application.
Sure. And so in this way, really one of the things that we want to focus on is that it's a brilliant concept that the application should be decentralized, and then it should be run by as many different computers owned by as many unrelated parties as possible. However, it's a damn shame to have 100,000 computers doing exactly the same work instead of finding clever ways to distribute them. Now, we want to work very carefully in the way that we design this platform to allow each decentralized application developer the freedom to configure the level of redundancy and political decentralization compared to the level of ability they would like to use to distribute the actual amount of work required by their as is needed by their particular application. We disappeared there for a second. Hopefully the audio is still recording.
Who knows?
But in any case, I think
yeah, the idea is really the leaving the blockchain part to the blockchain, offer a set of native services that apply to all the kind of transaction, also for the decentralized application. You want to escrow a transaction for a decentralized application? Let's say I do a transaction for a smart contract in Ethereum. I want to escrow it, meaning I want a third party to authorize on my transaction. In the case of Ethereum, we need to code inside smart contract also the escrow. In the case of ZooBC, this is part of the core functionality of the blockchain. So doesn't matter what kind of transaction it is. You want to have a blockchain object representing an asset, a digital twin. You need to create the ERC, whatever, in order to have it, and people that has to deal with this has to make sure there is the correct code, etc., etc. In ZooBC, this is native. Then the object can be treated by the centralized application, can be exchanged by people, but is not the application that decide who owns it or why. This is something that is taken care by the blockchain. This gives a very strong guarantee to the user that certain set of things are taken care of properly because they're managed by the blockchain. This fancy functionality, those are given on to
So let me try to summarize this way, because we've started to get the question a lot recently about why doesn't ZooBC version 1 support smart contracts? Don't you care about decentralized applications? The whole market is about decentralized decentralized applications now. And I would say that not only do we care about decentralized applications, we care about it so much that we didn't do the half-assed step of making yet another smart contract platform, a clone of all the others. Instead, we built what we know is going to work nicely for now, and we continue to build the thing for the future, which is going to work radically differently, which is going to enable types of decentralized applications that have never been possible with smart contracts on a platform. And that's what we're shooting for.
Yeah. So with this, and with the accident we had at the beginning, we close the day. That's our take on smart contract. And this is Barton, and this is myself, Roberto. And we meet you next Monday, 3 p.m. Singapore time, and there is always in the description all the other times in different time zones. Because our things are broken, we need to go there on the back to stop the streaming.
Pretend that we're not on camera anymore.
Pretend that you're only watching.
3, 2, 1.